Hello and welcome again to my Physical Science Online Video Lecture Supplement series. In today's video, I'm going to be doing a post-quiz review. This is a post-quiz review for the reaction time quiz for my online physical science lab. Since this is the first of the quizzes, and hence this is most likely the first of the videos you're watching within this series of post-quiz reviews, at least for the physical science lab, I should give a little explanation before launching into the video itself. The process that I'm going to be using in making these videos is basically this. You all will take the quiz, those of you who are taking this course from me. You'll take the quiz, you'll submit it by the deadline that is listed in the course. Then sometime after that, and I will try to always do it within the same week that quiz is due, if it's due at the beginning of the week, or within 1 week if it's being due otherwise, I will try to have one of these videos made and posted, and this video will go over all of the questions that are on that quiz. And the way that I'm going to do most of these is I'm going to open up the quiz itself in Blackboard, which is like this. I will click the begin button and I'll just walk through the questions on the quiz. So this is a post-quiz review, all the questions on the lab quiz. So let's begin, and this also will give you some idea of how you should enter numbers, that kind of thing, because there's always questions about that after the fact. And before I begin, one other last little comment, which is as soon as this video is posted and available within the course, it means that I have effectively posted the key for the course. So that means that any quiz that is submitted after that is officially late, and therefore is going to have some late penalty assessed. And if you don't contact me in advance to let me know that it's going to be late, then the late penalty is going to be fairly severe. And this is just because I don't want people to come up with the idea of saying, gee, I haven't done very well in the last 3 quizzes, so therefore the odds are in my favor if I take a 20% late penalty that I'm going to get 80% on this quiz, and I've been only averaging about a 40%. That's not going to cut it. You've got to let me know before I would reasonably post this video, simply because I don't want people coming in taking the quiz well after the answers are already available to the whole class and then saying, see, I came out of this class with a B because I just waited until the videos were available every single week. Not that anybody has necessarily done that, but just to head that possibility off at the pass. So you've all been warned. So let's begin this quiz. Maybe. Alright, so the first question on the quiz: which of the following things do you measure directly in this lab? The distance which the meter stick falls using a meter stick, your reaction time using a timer, your friend's reaction time using a timer, or none of the above. So let's pull up the directions that you have for this lab, and we're going to kind of scroll through these directions and we'll see what it says. Basically, under summary of the experiment, you will be measuring your reaction time with your left hand and with your right hand. To do this, you will have a friend hold a meter stick vertically, so that its bottom is just above your hand, which you will then hold in such a way as to be able to catch the stick when it is dropped. Measure how far the stick has fallen in each case in units of meters. So the thing you're measuring is how far the stick falls. From that, you can then calculate a reaction time, but the thing you're actually measuring is how far does the meter stick fall. So therefore, the answer is distance which the meter stick falls using a meter stick. Which of the following do you end up comparing? and this is sort of a select all which apply. If it's a rectangular box, it means select all which apply. If it's a circle, it means only one choice is possible. I can only pick one of these things. On this, I can pick as many as I want. Okay, so you're going to compare at least two things. But if you look in the options, you'll notice that there's always two things listed in an option. So your left hand reaction time to your right hand reaction time, your friend's right hand to his left hand, your right hand to your friend's right hand, your left hand to your friend's left hand, or none of the above. So just pull open the directions again. So far it's basically your hand and your hand. Scrolling through, you calculate some reaction times. Scrolling through, you do this a bunch of times. It's still just you catching it. Then there's some percent differences. That would be the comparison. And ultimately, that's it. Then there's some further exploration, but that's not going to usually show up on the quizzes per se, other than maybe occasionally as a bonus question. So basically, you're going to compare your left hand reaction time to your right hand reaction time. Your friend doesn't show up anywhere in here, so none of these others are correct. Number 3, if your reaction time is fast, then which of the following? The stick will fall a long distance, the stick will fall a short distance. Your reaction time is not correlated with how far the stick falls. Well, or none of the above. Given that the way that we're calculating reaction time is we're measuring how far the stick falls and then going from there, I think we can eliminate a couple of these options here. It needs to be one of these two. It has to be that either the stick falls a longer distance for a faster reaction time, or it has to be a shorter distance for a fast reaction time. So one of these two has to be the correct answer. Now let's look in the handout, and if we scroll down, it says here's how you can calculate your reaction time. Time in seconds is 2 times distance in meters divided by 9.8. The actual equation, by the way, is given symbolically by something like this. Basically, it is that time in seconds is equal to square root of 2 times distance in meters divided by free fall acceleration or gravitational acceleration in meters per second squared. That actually is the full equation. This is equivalent to t is equal to square root of 2d over g. Be that as it may, if your reaction time is fast, then the implication is that t is relatively small. So faster reaction, smaller t, smaller time. Well, since this right here is constant, the implication is that if t gets smaller, then d also has to get smaller. In other words, the faster your reaction time is, and therefore the quicker that you catch the meter stick, the less time that it has to fall, and therefore the less distance that it's going to be falling. So that means that the answer here should be that for a fast reaction time, the stick should fall a short distance. Now, question 4 says your friend drops a meter stick and you catch it after it's fallen 15 centimeters. What is your reaction time for this in seconds? Okay, so we're going to use this equation now. Now we're given that the distance that this thing falls is 15 centimeters. That is, by the way, 0.15 meters. Reason why we need to do this is because this says that the distance should be in meters. So t in this case is going to be square root of 2 times d, which would be 0.15 meters, divided by free fall acceleration, which is 9.8 meters per second squared. So this right here, you're allowed to use calculator on these quizzes, along actually with the handout and any data you have. So everything that I'm showing you right here is material that you are validly allowed to use and have in front of you while you're working on the quiz. The only thing that you shouldn't have is this video itself, or somebody else's notes or that kind of thing. So no cheating, but this is valid. So the way that I have to enter this into my calculator is I basically say 2 times the distance, which is 0.15. I have to divide that by 9.8, and then all of that is under a square root. So after I've done all this, I hit the square root button and I get a number. So this number is the time. So 0.17496, basically 0.179 seconds, but I see that there's only two significant figures, so this is more like 0.18 seconds. So how should I enter this? It says, what's your reaction time in seconds? Well, I've got my reaction time in seconds. The part that I actually need to enter into the box is just the number. So I go 0.18 and then I move on. Suppose you drop the meter stick and it falls 25 centimeters for your left and only 15 for your right. How much faster is your right-hand reaction time than your left-hand reaction time? And then it says you should calculate this to at least 3 decimal places. The reason for that, by the way, is that if you don't take it to at least 3, then you might not get a very significant reaction time for both of these. Certainly not a very significant difference. So actually, if you're paying attention, you notice that I just worked the version for 15 centimeters. So this is like the time for the right hand. Now for the left hand, we had 25 centimeters or 0.25 meters. So what that means is that the time for the left hand is the square root of 2 times 0.25 meters divided by 9.8 meters per second squared. By the way, the next digit here, depending upon whether you live up on a mountain or not, is basically going to be a 0. So let's pull open our calculator because we got to calculate that guy now. And what this guy is telling us basically is we have 2 times 0.25 divided by 9.8, and then we take a square root and we get 0.2258. So this one, 0.225876, so maybe 0.2259 seconds. This one right here, actually out to that many decimal points, 0.17, and then the next digit is a 4 and then a 9.6. So this actually is 0.1750 seconds. I'm taking it out to more decimal places than I need just because I know that I'm going to have 3 decimal places in my answer, so this is just to be on the safe side. So now I need to basically get myself a little more workspace here. And so what I do is I want to know what the difference in the times is. So I'm going to call that delta t. And it's going to be defined as the absolute value of whatever, the left hand minus the right hand. If I do it in reverse order and take an absolute value, I'm going to get the same number anyway. So this is just to make sure it's a positive number. So I would have 0.2259 seconds minus 0.1750 seconds. And So that, if I subtract those two from each other, what I'm going to get is, so let me subtract the 0.2259, and I get something like this. Of course, I didn't truncate this guy, but that's okay. Take an absolute value, and what you end up with is 0.0509. So 0.0509 seconds. This right here is to 3 decimal places. The 509 are significance. So what I need to enter here onto my answer would be 0.0509. Question number 6. Basically, you're told that your friend is going to drop a meter stick and then you're going to catch it. And then you do that for 5 times, and each time you write down how far the stick falls. And wants to know what's the average distance the stick falls. Question 7, by the way, asks for the same set of data. And I hope that you guys are paying close attention enough to notice this when you take these, that sometimes I'll have 2 or 3 questions that are kind of related, and so they'll use the same data somehow. That will save you the effort of having to recalculate stuff, although if you do recalculate it, it may serve as a nice double check. So in any case, these 2 questions basically are using the same sets of data. So I'm going to work both of them together, because the questions are what's the average distance, and then this one says what is the average reaction time, which we should do by first determining the times which correspond to each distance. And this one says in meters, by the way. So let's pull that thing up. Basically what I'm going to do here is I'm going to make a little table. And what this table has is it's got the trial number. It's got the distance that it's fallen in centimeters. It's going to have the distance that it falls in meters. It's going to have the time for each of these trials in seconds, and then we're going to have the averages down here. So let's go ahead and fill out the table, which is, this is the information that was actually given to us in this quiz. And basically this right here is the answer to the question at hand. This right here is the answer to the next question. Alright, so let's go ahead and we can actually get the average of these 5 numbers. Remember that the average is given by adding the numbers together and then dividing by the number of trials, which in this case is 5. So we will represent that using average distance, which is going to be represented by a D with a bar over it. So D bar is equal to 1/5, because there's 5 trials, times 7.0 plus 16.0 plus 13.0 plus 7.0 plus 12.0, and that's in centimeters. So let us go ahead and plug all that into a calculator. So 7 plus 16 plus 13 plus another 7 plus 12. That gives us 55. So our average, therefore, D average, is 1/5 of 55 centimeters. And so that gives us, should say 55.0, that gives us 11.0 centimeters. So we can write 11.0 in here. Now, actually, I think I'm going to go ahead and put the calculated terms in blue. Okay, so now we need to convert to meters. And the way that you do that is you move the decimal 2 places over to the left, because 1 meter is equal to 100 centimeters. So that means that 1 centimeter is equal to 0.01 meters. All right, so that means that 7 centimeters must be 0.070 in the meter scale. This is 0.160, 0.130, 0.070, and 0.120. So I can repeat this averaging guy again. D average is equal to 1/5 of 0.070 plus 0.160 plus 0.130 plus 0.070 plus 0.120, and this is all in meters. Alright, so if I do that in the calculator, what I'm going to get is 1/5 of 0.550 meters, or 0.110 meters. Notice also that if I move the decimal place 2 places over here like I did over here, I will get the same answer. So 0.110 is the answer in meters. So now I should be opening up this quiz and putting it in 0.110. This is how far the stick is falling on average. Notice again that I did not enter units here, and notice that I picked the answer that actually was in meters. That's what questions like this basically are saying. So now I need to calculate the amount of time that the stick falls in each of these drops. And basically what I do is I use this equation over and over and over again. So for example, here I'm going to have square root of 2 times 0.070 meters divided by 9.80 meters per second squared. And so for each of these lines, I replace this 0.007 with whatever number happens to be on the line next to it. So I'm going to have to use the calculator again. So let's, I'm actually going to delete this thing from my table because I wanted to just write the numbers in here, but I'm showing it to you so that you have the formula in operation in case you want it. So we go 2 times 0.07 divided by 9.8, and we take a square root, and you get 0.1195. So this first time might be 0.1195. Notice that I'm keeping one extra significant figure here. So now we have 2 times 0.16 divided by 9.8, take a square root, and you get 0.1807. So this one is 0.1807. Next one down, it has now fallen 0.13. So we go 2 times 0.13 divided by 9.8. Take a square root, we get 0.16288. So we could write that as 0.1689 because it's going to round up. Oops, I left off a 2 there. So that's 0.1629. This one's a freebie because we have it already above, so 0.1195 again. And for our last one, we had 0.12, so 2 times 0.12 divided by 9.8. Take a square root and you get 0.15649, so 0.1565. 0.1565. Now we need to get the average time. So the average time we find in a similar manner to the average distance. You go 1/5 of, and then you add these guys together. 0.1195 plus 0.1807 plus 0.1629 plus 0.1195 plus 0.1565, and that is seconds. Okay, so now we pull up the calculator. What we need is 0.1195 plus 0.1807 plus 0.1629 plus 0.1195 again plus 0.1565. So that is the total of adding all of those guys together. So our average time becomes 1/5 of 0.7391 seconds. Now we divide that by 5 and we get 0.14782. So 0.1482 seconds. Realistically, we have actually 3 significant figures to work with. This figure right here was not actually a significant figure in these calculations, nor should it carry over into this final answer. So we would put 0.148 seconds. So now we open up this guy and it says, what is the average reaction time? 0.148. Okay, question 8. Suppose your right hand has an average reaction time of 0.15 seconds and your left hand has an average reaction time of 0.25 seconds. What is the percent difference between these two? Then it says you do not need to enter any plus, minus, or percent signs in your answer. Okay, so let's go ahead and do that. What I'm going to do is pull open the lab handout again, scroll down, because it tells us that the percent difference, or PD, between two numbers is given by this equation. It's basically y minus x divided by the average y plus x, so the average of y and x, times 100%. And more properly, it has an absolute value. And this one, similarly, you could take an absolute value for. So that means that we can ignore the plus or minus of our entire answer in case one is bigger than the other. Another way of saying that is, if you're comparing y and x, it doesn't really matter which thing you take to be x and which one you take to be y, so just put the bigger number first. So here's our percent difference formula in terms of these two times. So therefore we can write that the percent difference is 0.200 seconds minus 0.150 seconds divided by 0.200 seconds plus 0.150 seconds divided by 2 times 100%. Okay, so let's go ahead and consider what our order of operations is. Basically, you can treat this entire quotient as if there's a giant parentheses around it. So the very last thing you do is this multiplying by 100% step. You have to do everything in the numerator and everything in the denominator before dividing the numerator by the denominator. And then within the denominator, everything inside the parentheses has to happen before dividing by 2. So our order of operations is that we add these two numbers together. So 0.2 plus 0.15 gives us 0.350 seconds divided by 2. This top part you can do simultaneously. The difference between 0.2 and 0.15 is 0.050 seconds. So our percent difference, in other words, by doing those two things. We can divide 0.35 by 2, so that should give us 0.175. So 0.35 divided by 2. Alright, so the percent difference at this point says 0.050 seconds divided by 0.175 seconds. And then that is times 100%. So now we pull open the calculator. One way of doing this is if I put the 1 over x, that's like dividing 1 by this number, and then we can multiply by the numerator, 0.05. So this is the same answer that you'd get if you put 0.05 and just divided by that 0.175. So 0.2857 is the answer here, and then we need to multiply by 100%. So I go times 100. The answer is 28.57. So this is 28.6% or 26.57%. Pulling open this thing here. Basically, it says what's the percent difference between these two numbers. Whoops, this was 0.25. Oddly enough, the second question is 0.20, so I actually just answered the second question, not this first one. So 28.5 goes to question 9. Very sorry about that. With that said, for this one right here, we can redo the calculation. So this is basically Q9. For Q8, it's basically all the same process that we just went through, except for that in Q8, your right hand is still 0.150 seconds, but your left hand is more like 0.250 seconds. So your percent difference becomes 0.250 seconds minus 0.150 seconds divided by 0.250 seconds plus 0.150 seconds divided by 2, and then that's times 100%. So this percent difference, basically you have 0.100 seconds on the top, you have 0.400 seconds divided by 2 on the bottom. That's times 100%. And so your percent difference here, this right here, is actually 0.200 seconds when you do that. So you have 0.1 over 0.2, that would be 0.5. And then you're timesing that by 100%, so that would be 50%. So you have a 50% difference for question number 8. So here we just enter 50. Alright, so we do a quick once over to make sure that all of our answers are correct, correct to what it is that we want to submit. So these are basically the answers that I actually want to submit. Do a little bit of a double check, hit save and submit, and we come through and we check. It says you got a score of 100 out of 100. That basically means that all of the questions were correct. And if we scroll through, 12 out of 12, 12 out of 12, 12 out of 12, 10 out of 10, 10 of 10, 12 of 12, 10 of 10, 10 of 10, 12 of 12. So that is the correct answers to everything on this quiz. Hopefully you found this video helpful, especially if you didn't do as well on the quiz as you would have liked to. And I hope you do better on the next one if you didn't do as well as you'd like. And for those of you who did well on this quiz, keep up the good work. Thanks for watching.